Thanks to Bram Stoker's iconic novel Dracula, Transylvania in Romania has become a land iconic for Gothic horror. However, if you were to travel back to the end of the Cretaceous period, you would discover the reason that paleontologists today view the region very differently. You see, throughout much of the Mesozoic, Europe was a series of islands, and during the final 4 million years before the dinosaurs died out, Transylvania formed part of what was referred to by paleontologists as Hateg Island. Based on the geological record, Hateg Island would have been covered in dense subtropical forest and was home to a host of unique and unusual dinosaurs and pterosaurs, which in their isolation evolved very differently from those on the mainland continents. We will be talking about all of these dinosaurs to some extent a bit later in the video, though perhaps the most strikingly unusual of all of the dinosaurs on the island is a dog-sized theropod known from a partial skeleton discovered in 2009 and from some previously mysterious arms which were discovered in 1997. The remains were described by Dr. Zoltan Csiki and colleagues in the Proceedings of the National Academy of Science in 2010. The bones, collected from floodplain silts, represent the most complete theropod known from the late Cretaceous of Europe, and show a number of very unusual anatomical features. For example, despite having a very dromaeosaur or raptor-like body plan, this creature has a greatly enlarged first toe on each foot, effectively giving it 2 sickle claws, and a greatly reduced third finger, with relatively small hands ill-suited for grasping. Csiki et al. Named the remains Balaur bondoc, with the genus name Balaur referring to a many-headed dragon from Romanian mythology, and the species name bondoc simply meaning stocky due to the animal's squat, robust shape. The stocky little dragon's bizarre hands showed extensive fusion, with the carpals and 3 metacarpals being fused into what's referred to as a carpometacarpus, a feature typical of Alvarez saurids and derived birds, but unusual for dromaeosaurs. The third digit was described as a small nubbin and was entirely vestigial, not even having a claw. You probably wouldn't even be able to tell that it had a third finger by looking at it. The pelvis is also strikingly bent backwards at far greater than the typical 45-degree angle seen in other paravians, that being the group of feathered theropods which includes dromaeosaurs, birds, and a whole host of other cool animals. The bones of the hind limbs are also extensively fused together in a manner which is similar to what is seen in modern birds. Balaur shares a number of features in common with dromaeosaurs like Deinonychus, Velociraptor, and Linhoraptor, including a deep groove on the back of the humerus and its sternal plates being separate and ossified, i.e. turned into bone, with the scapula and coracoid being fused into a scapular coracoid such as is shared with Velociraptor and Microraptor, both of which are dromaeosaurs, and with Pneumatoraptor, which is some kind of paravian, but we don't actually know which kind, and only have a scapular coracoid from it. Anyway, whilst all of these features indicate that Balaur was a dromaeosaur, Csiki and colleagues also noted a number of strange features which seem to contradict this interpretation. For example, as mentioned before, the fusion of the hand bones was more typical of birds than of raptors, and the use of 4 toes to walk on rather than 3 is also more typical of birds, though it's also seen in the therizinosaurs, which were a group of huge, giant-clawed herbivorous paravians. So, With all of this strange mystery, Csiki and colleagues ran a phylogenetic analysis. That's a way of using a computer model to analyze the features of the specimens and work out what's most closely related to what. And they determined that Balaur bondoc was an unusual velociraptorine dromaeosaur, and actually the closest known relative to Velociraptor itself. Despite this apparently close relationship to Velociraptor, Csiki and co. noted that the taxa were significantly different. They interpreted the morphology of the legs with their fused bones, short length, and weird pelvis morphology to indicate that the animal was built for strength, with its feet armed with 2 killing claws being used to deliver extremely powerful slashes and strikes to kill prey. They interpreted that its morphological differences from other velociraptorines was the result of its separation on Hateg Island. In 2013, paleontologist Dr. Steve Brusatte and colleagues wrote a very large and in-depth study into the bones of Balaur, which was far too detailed to discuss in depth in this video. Despite some clearly painstaking and frankly incredible work and documentation of skeletal features by Brusatte et al., their phylogenetic analysis of Balaur was somewhat ambiguous, finding it to be either closely related to Velociraptor, as with the prior study by Csiki et al., or to be more closely related to Deinonychus and Adasaurus, or to lie outside of the clade containing Deinonychus and Velociraptor. Brusatte et al. Argued that if cranial material is discovered, it would significantly help resolve the relationship between Balaur and other dromaeosaurs. Brusatte et al. Also noted that, consistent with the dwarfism noted in other dinosaurs from Hateg Island, Balaur appears to have been somewhere between 15% and 34% smaller than its closest relatives on the mainland, though given that the specimen is both incomplete and unusually proportioned, they note that it is possible that the small femur of Balaur, which was used to estimate its body size, might not actually be indicative of island dwarfism, and that it might still have been around the same size as Velociraptor. After this study, other works would be published that would challenge all that we thought we knew about Balaur, including whether or not it was actually a dromaeosaur at all, or something altogether more familiar to those of us living in the modern day. Brusatte et al. Themselves noted in their monographs that the degree of fusion in the legs of Balaur was more typical of avialans, i.e. birds, than of dromaeosaurs, and the number of similarities between Balaur and primitive birds was getting very hard to avoid noticing. In 2013, paleontologist Dr. Pascal Godefroit and colleagues described the primitive bird Aronis zui. Aronis was very important as it provided sufficient data to resolve the relationships of Archaeopteryx as being a true primitive bird, well, technically avialan as the definition of the group does go a little bit beyond birds, but it indicated that powered flight had probably only truly evolved once within avialans, rather than on separate occasions as had been argued by other studies. I will note that powered flight does seem to have evolved separately within the microraptorine dromaeosaurs, but they weren't avialans, just very close relatives. Anyway, this study's phylogeny found that Balaur was actually more likely to be a primitive bird than it was a raptor. Balaur was interpreted to be most closely related to Shenzoraptor, Rahonavis, and Sapiornis, all of which diverged from the bird lineage before the modern group had evolved, and thus still possessed claws and toothy mouths with no beaks. I must say that looking at this Sapiornis specimen, the resemblance of the hand to the hand of Balaur is striking and impossible to not notice, with that similar, greatly reduced, highly fused, clawless third finger. That said, Godefroyd's study, despite having some very important findings about Balaur, doesn't actually talk about Balaur at all beyond showing the results of this phylogenetic analysis. In 2014, a phylogenetic analysis by Dr. Christian Foth and colleagues studying a new specimen of Archaeopteryx also found that Balaur was an avialan, or bird, with their analysis finding it to be much more primitive in the bird family tree, being the closest known relative of Archaeopteryx and lying evolutionarily between it and Epidexipteryx. In 2015, the paleontologists Dr. Andrea Cow, Dr. Tom Browham, and Dr. Darren Naish decided that they needed to get to the bottom of things and put their heads together and performed a study where they both qualitatively compared the skeletal elements of Balaur with dromaeosaurs and with primitive birds, and quantitatively assessed the competing phylogenetic interpretations. They noted that if Balaur is a velociraptorine, then it's striking just how many features they would have had to have evolved in convergence with birds. Indeed, when they compare the hand of Balaur on the left of this diagram with two primitive birds in the middle, and then with a dromaeosaur hand on the right, it's pretty clear which of these Balaur has the most similarities with in terms of bone fusion, bone number, and structure. Indeed, virtually all of the weird features of Balaur's skeleton become much less unusual when viewed through the lens of it being a primitive bird, and this was the outcome of Cow and Co.'s analysis, with the morphology of the feet using 4 toes to bear weight instead of 3 also being much more typical of primitive birds. Cow et al. Therefore argue that Balaur was a secondarily flightless bird, related to the most basal of all fossil birds, and was descended from flying ancestors. Balaur's ancestors would have presumably lost their flight after colonizing Hateg Island, much as is seen in many island ecosystems today, for example with the kakapo or owl parrot and the kiwi in New Zealand, and with the dodo in Mauritius. Regarding the ecology of Balaur, Cow and colleagues have a different opinion to the 2 preceding papers. They argued that its hands being poorly suited to grasping prey, as was also noted by both Csiki et al. And Brusatte et al., seems to indicate that it might not have been a hypercarnivorous predator, and noted a number of skeletal characteristics around the chest and pelvis that seem to have convergently evolved with the herbivorous therizinosaurs, and may support that the animal had a larger gut for digesting plant material. They therefore suggested that Balaur might have been a primarily herbivorous or at least omnivorous animal. Indeed, it is odd that a predator would lose hands ideal for catching prey upon entering an island habitat, when all of its closest relatives, if it was a dromaeosaur, had big, graspy hands. Interestingly, Balaur wouldn't have even been the only secondarily flightless bird on Hateg Island, as it shared its habitat with the giant Gargantuavis. So, if Balaur was a herbivorous or omnivorous animal, what the heck was up with those fricking feet? Well, Cow et al. Noted that these enlarged claws were quite typical of the morphology of the toes of many early birds, and had a lot more mobility than was present in dromaeosaurs. It's possible that these feet may therefore have been more adapted for climbing around its forest home, rather than for brutally slashing at prey like Csiki et al. Originally proposed. An alternative hypothesis was actually proposed for the large claws by Zoltan Csiki himself back in 2010 in a rather tongue-in-cheek comment given to the writer of this article in Discover Science magazine, where he suggests that they may have used their claws to dig out root tubers for food. Admittedly, he does specifically say carrots. For some reason, I don't think that the carrot family would have existed back then. Feel free to correct me on that. But anyway, although it's easy to see this debate regarding the relationships of Balaur as resolved at this point, and simply to say, "Oh, what a cool bird that was," the phylogenetic results of some studies, such as those by Turner et al. And Napoli et al., both in 2021, and weirdly both in the same journal, have still found Balaur to be an extremely unusual derived velociraptorine dromaeosaur. Personally, I am convinced that Balaur was a bird, but I'm not quite as convinced that the feet are consistent with a herbivorous lifestyle. I think it's likely that Balaur was an opportunistic omnivore. That said, I am happy to be proven wrong when more material of this fascinating animal is hopefully uncovered. A discovery of a skull in particular would greatly help to resolve its ecology and massively help us understand who it's most closely related to. Whilst these taxonomic shifts might seem very drastic, much of the reason that they seem so is because of how we as humans tend to view birds as different from dinosaurs. As Darren Naish discusses in his article in Scientific American about Balaur's taxonomy, whether or not Balaur is a bird or a dromaeosaur really only moves it between 2 to 4 nodes on the taxonomic tree because of how closely related the early birds were to dromaeosaurs. As Darren notes, many other groups have had far larger shifts in their evolutionary position as more data has been added. For example, the megaraptorans, whose evolutionary position within theropods is seemingly constantly shifting from being allosauroids, non-tyrannosauroid coelurosaurs, and tyrannosauroids as more evidence is gathered. Indeed, the recent study on Irritator challengeri that just came out, their phylogeny just moved them back to being allosauroids, so I don't think anything is anywhere near as close to be resolved with them as we had thought it was. But that might be a topic for a future video. I don't know yet. I feel like quite a few people have already done videos on Megaraptorans, and I might wait for another big Megaraptoran to be discovered before I do that, just in case that massively clears up the Megaraptoran taxonomy situation. The Balaur situation only feels like a bigger issue because of the artificial separation that our familiarity with birds creates in our mind between birds and dinosaurs. We need to remember that birds are not merely the descendants of dinosaurs, but are dinosaurs themselves, and represent the last surviving lineage of coelurosaurian theropods. Balaur would have lived alongside a host of mostly very small dinosaurs compared with those on the mainland. These include the dwarf hadrosaur Telmatosaurus, the tiny dwarf iguanodont Zalmoxes, and the dwarf sauropods Magyarosaurus dacus and pallid titan Nalotzensis. These sauropods were both only around 6 to 8 meters long, despite being titanosaurs, belonging to the same radiation of sauropods as giants like Argentinosaurus and Dreadnoughtus. The island also contained the pint-sized nodosaur Struthiosaurus transylvanicus, the giant flightless bird Gigantuavis, and a host of small theropods known from much more fragmentary remains. Balaur would have had to contend with 3 larger predators that we know of, all of which would probably have viewed it as a tasty snack. The first is a mysterious small or medium-sized theropod, which was named Megalosaurus hungaricus by Baron Franz Nopske in his 1902 description of the species. Megalosaurus hungaricus was only described from a single tooth, and it is now no longer considered a valid taxon, since there wasn't enough material to really diagnose it. However, we can be very sure that it was not a member of the genus Megalosaurus, and that it almost certainly wasn't even a megalosauroid, since it lived around 100 million years after Megalosaurus itself went extinct. The youngest megalosaurids that we know of also come from the Jurassic, being much older than this specimen, and though megalosauroids as a group extend quite some way into the Cretaceous in the form of the Spinosaurids, this sure as heck does not look like a spinosaur tooth, which were long and pointy and sort of crocodile tooth-like. If you are confused as to why Nopske called it Megalosaurus, well, at the time, unfortunately, the genus Megalosaurus was really being used as a massive wastebasket to call pretty much any old medium-sized theropod remains and classify them under. Which is annoying, but oh well, I guess back then people just saw these similar looking things and assumed they were closely related. In their epic 2012 paper on the phylogeny of Tetanuran theropods, Matthew Carano and colleagues noted that the morphology of the tooth that was called Megalosaurus hungaricus by Nopske was most consistent with it either being a tyrannosauroid or a dromaeosaur. If Megalosaurus hungaricus was a tyrannosauroid, it probably would have been similar to that other small European tyrannosauroid Eotyrannus from earlier in the Cretaceous, which I'm probably also going to make a video on at some point in the distant future because it was a very fascinating animal. At the moment, though, we can't confidently say what type of theropod this thing was, and given how fragmentary the mid to late Cretaceous theropod record is from Europe, I don't really think we can necessarily even rule out the theropod groups that went extinct elsewhere from potentially having held on. Hopefully, one day more remains will be found and we'll actually know with confidence what this mystery predator was and who it was most closely related to, and what it actually looked like. Tetanurans, by the way, are all of the theropods which are more closely related to birds than they are to Ceratosaurus. So, basically all the theropods you can think of except for the ceratosaurs and some of the primitive ones. The other 2 predators in its ecosystem were both pterosaurs. There was the medium-sized Azhdarchid Eurasdarco langendorfensis, and the island's apex predator, the freaking huge, highly robust Hatzegopteryx dambina, which has an estimated wingspan of 9 to 10 meters. So, as you can tell, Balaur's ecosystem was every bit as bizarre and fascinating as Balaur itself, and is still quite mysterious to us, likely housing many more interesting and unusual creatures yet to be discovered. Thank you for watching, everyone. I would really appreciate if people would like, share, subscribe, and support the channel via Patreon, where I'll be updating you on the progress of each video, allowing you to vote on future videos, and providing sneak peeks of my paleo art and giving you a chance to vote on that, as well as voting on future videos. You can also check out my Redbubble store, and you can donate to support the channel via Ko-fi. Thanks again for watching,